up W1. So we're talking about the 4 problems here. All right. We're going to start talking about the fundamental theorem of calculus. It sounds complicated, but it's really not, because we've already kind of talked about it. A nice pattern that's emerged as we work with answers to polynomials is this right here. So the fundamental theorem of algebra says that the power or the degree of a polynomial will have that many answers. Okay? So, meaning, and I feel like that's still a little fussy, sorry. There you go. What this means is that, like with a quadratic, we always get 2 answers. With a cubic, we'll always get 3. With a linear, you always get 1. So the power, the degree, matches how many answers you should have at the end. Okay? So we need to know this fundamental theorem of algebra, that the power will match the number of answers, because when we're working backwards, like in these 2 scenarios, you have to know what type of function you should have at the end. For example, using the fundamental theorem of algebra, we're going to write an equation of a polynomial. Now, a polynomial just means that you have many terms. It could end up being a quadratic, but in this case it's not. Could end up being linear. They're all polynomials, because this just means many terms. But we're going to write an equation of a polynomial that has 3, -2, and 5 as answers, or x-intercepts, because that's what your answers always mean. Like when we're dealing with quadratics and you get to your 2 answers, those mean the 2 x-intercepts. So these are my 3 answers that I'm going to work backwards. Now, because there's 3 answers, that means my degree will be 3. So this is going to end up being a cubic function at the end, which means that we can't set it up like we were setting up these ones, because they're not quadratic. So we're going to set this up a different way. Now, we have to review a little bit. Something like this. Okay. So if I said find your answers here, find where this is equal to 0. This is already factored. When you're factored and you are set equal to 0 to solve, you just take each parenthesis and set it equal to 0. So here I would get -3 as an answer, and here I would get 10 as an answer. So we have to back up the process here. We're given our answers, so we're given these numbers here. We have to rewrite them as factors and then multiply them together in order to get to my original problem. So I know this is going to be an equation, so I'm going to have y equals. In order to get 3 as an answer, I would have to have x minus 3 as my factor, so that's what I'm going to start with. In order to get -2 as an answer, I would have to have x plus 2 as my factor. In order to get 5 as an answer, I'd have to have x minus 5. You can always double check your work by seeing, okay, if I set that equal to 0, then I get 3, I get -2, I get 5. Now from this point, we're going to simplify by multiplying together. Since you have 3 parentheses here, we're going to deal with one at a time. So we're going to take x minus 3 and x plus 2 and multiply them together using FOIL. So first terms give me x squared, outer terms give me 2x, inner terms give me -3x, and outer terms give me -6. Simplified, gives me negative x minus 6. That. Okay. And then we're going to have to multiply these together. Now, we can't use FOIL here because you have 3 terms in this one. But FOIL is just a fancy way or a method to distributing. So we're going to distribute. Now, when you distribute, you have to distribute the x to each term and the negative 5 to each term. So we'll do it one at a time. We're going to distribute the x through. So x times x squared is x cubed. X times negative x is negative 2x. Or sorry, negative x squared. X times negative 6 is negative 6x. Then we deal with the negative 5. Negative 5 times x squared is negative 5x squared. Negative 5 times negative x is positive 5x. And negative 5 times negative 6 is positive 30. And then we're going to add like terms. You have negative 1x squared, negative 5x squared, so that gives me negative 6x squared. Negative 6x plus 5x gives me negative x, and then plus 30. Okay, so you have now written the equation based on my original answers. So this is the 1 type of 4 type problem. The pattern of complex roots within a polynomial. What this is saying is, like, if you're given an imaginary answer its conjugate is also an answer. So if you're given an imaginary answer, its conjugate is also an answer. I don't know if we've talked about the conjugate yet. We might have. But conjugate is if you have a plus bi, then a minus bi is an answer. So usually we see these like plus or minus. But they're both. Now this is just something you need to know, but I will give you, for this standard, I will give you both of these answers if we're going to list them. Such as, we're going to write the equation of a polynomial with x-intercepts, which is another way to say with the answers, of 3, negative 2 plus 3i, and negative 2 minus 3i. Okay, so we have 2 complex answers because you have imaginary numbers, and then a regular number. Now, if we set this up the same way we did up here, it would look super, super complicated because you have like 2 parts to one answer. So to take care of complex numbers, there's a pattern that emerges that we can use to simplify this problem. So with complex roots, use the pattern x squared minus some x plus product. To multiply those factors together. The fact that there's this pattern that happens with the sum and the product of these 2 numbers is super beneficial for when we have to do the work here. So, for example, if we set it up the same way we did before, to get 3 as an answer, I'd have to have x minus 3 as a factor. To get this as an answer, I'd have to have x minus negative 2 plus 3i. To get this as an answer, I'd have to have x minus negative 2 minus 3i. Like that. So this is an issue because to FOIL those together would be ugly, to say the least. So when we're multiplying these 2 together, you kind of come up to the side here, and we're going to use this this pattern. Because if we were to FOIL this together and go through that long, ugly process, because because there's so many parts to this, it would end up following this scenario, where the first term will be x squared, the second term would be a number that you get when you add these two numbers together, and this would be the product of when you multiply those two numbers together. Which, when you factor, that's exactly what happens. The numbers at the end are the, like, remember when we factor, we're trying to find two numbers that multiply to get this number and add to get the middle. Well, that's basically what we're setting up here. So I do the sum kind of off to the side, where we add these numbers together. So negative 2 plus 3i, and then we add negative 2 minus 3i. What happens is that the i's cancel out, and you're left with just negative 4. Negative 2 minus 2. Circle that. Product is what you get when you multiply these together. Okay? So first terms give me 4. The outer give me positive 6i. The inner give me negative 6i. The outer and the inner will always cancel because these are conjugates, and that's what happens with conjugates. Outer and inner cancel. Last terms give you negative 9i squared. But remember what I squared is? I squared is negative 1, so that would turn to a positive 9 to get you a product of 13. Now what these two numbers, or where these two numbers go, are into this pattern. So we've basically kind of foiled them together, and we're putting them into something else that we can actually multiply the x minus 3 by. So we have y equals x minus 3. And then we have x squared minus the sum x. So since my sum is negative 4, it's going to be plus 4x. And then plus 13. Okay? So normally we would FOIL those together. We do technically FOIL them together, but we do it separately. We find the product of them, we find the sum of them, and then we just stick them into the pattern that we know is true. And then from that point, we can multiply them together. So again, I'm going to distribute the x through to each term, and then the negative 3 to each term. X times x squared is x cubed. X times 4x is 4x squared. X times 13 is 13x. Negative 3 times x squared is negative 3x squared. Negative 3 times 4 is negative 12x. And negative 3 times 13 is negative 39. And then simplify by adding like terms. So we get negative or plus x squared plus x and minus 39. Okay? Now, I know this is a lot here, but it's related to the standard because it's W1. I can write an equation of a quadratic is our goal here, but then extending to polynomials is the next goal. So we've extended it to polynomials with just regular numbers as answers, and then also when we have conjugates or when we have complex roots, you still set it up the same way, but to easily FOIL this together, we do this pattern x squared minus some x plus product. Okay. Now you will get some practice on this next week. Obviously these are 4-type problems, so it's your decision to move on to this, but I would recommend, if you're feeling comfortable with the W1 problems on this page, writing equations of quadratics, that you push yourself and do extend, because this isn't impossible for you to do. This is very doable, especially if you feel comfortable with the previous questions on this page. But you still have to practice it. It's a 4-type problem. So I would recommend that you make sure you're good on the proficiency problems, and then extend and push yourself to work on these as well. That's it. Have a good weekend.